Okay, yeah. So usually when you use an ORM like Hibernate, I will not move next to the speaker. Usually when you use Hibernate, you don't really want to know what happens with the database because it's an abstraction and you use that to ignore the little details that you have in the database. But in some cases, it's interesting to see what is really executed, the SQL statements that are executed and how they are efficient or not. And that's basically the goal of this session, looking at a few mapping strategy to understand what can happen in the database when you use them. So maybe the defaults are not always good. Also, you will see that it depends on the different databases, the implementation. I'm Franck Pachot. I've always been working with databases, a lot of Oracle, Postgres. So my examples are more coming from that. Now I'm developer advocate for UGabyteDB, that is a distributed Postgres. If you want to scale out Postgres, it's a solution. And if you want to know more about it, please reach out to me at the conference. For the moment, what I'm showing is the general concepts with some examples about Postgres and Oracle because I know them, because when you go into the detail of what is happening in the database, all databases behave differently. So basically what we will see there, I divided a few mapping strategy in data ingestion. How can you ingest data efficiently? Also generating the identifier, fetching strategies, and a few things I've seen about working with documents, with pagination, with dynamic updates, where I've seen from the database point of view that it may not be efficient by default. And if we have time, we will look at a few data types, but it's not exactly performance. And if you have questions, we have this Slido link. I don't know where is my pointer, but okay. We have the link there, and I think you can type the question, but you can also interrupt me if you want, and I will look at the questions later. Okay, so to start, the most important for my point of view, and my point of view is from the database, the most important is to understand which SQL statement is built and sent to the database. And with Hibernate, you can show SQL, so at least you can see the SQL statement that it is running with a format SQL. Sorry, that doesn't work very well, but with format SQL, you can see it formatted in multiple lines. I usually don't need it because the most important thing for me is how many SQL statements are run behind, so you want to see them in lines. For example, here, whatever I'm doing, I see that I have many single row inserts. This is probably the most efficient if you have a lot of data to ingest. And I can see also some calls to next val, to a sequence, multiple calls. Do you really need to have those additional calls when inserting data? So I will start with the generated value for those multiple calls. So select next val, and then I have many inserts. I don't have one select from the sequence per insert, so that's already a bit optimized, but I have multiple ones. Actually, with the default, I have one call to the sequence every 50 rows that are inserted. And that's the default generated value strategy for most of the databases. You have alternatives. You can completely avoid this call to the select next val. For example, you can use the identity. So the default auto is sequence. It creates a sequence. It reads from the sequence the numbers. It reads 50 numbers, and then we'll use it. If you use identity, you see the difference in the SQL that is generated. Let me try to get the pointer there. The first one has the ID, because it has read from the sequence and then it inserts the specific value for the ID. The second one doesn't mention the ID. The database will generate it itself. And you see the create table, because show SQL also shows the table creation when you generate the DDL from Hibernate, which may not be the best idea except in a lab to test and see exactly how it maps. So here the difference is that this is on Postgres, and it generates a big serial data type that is a special data type that creates a sequence behind it. What is important to see is that the first one, when it creates a sequence, it creates it with an increment by 50, so that it doesn't have to get a number for each row. It will get a number, increment the sequence by 50, and then knows that it can use 50 values before asking for another one. So that's already an optimization. It is cached, the numbers, the range of number is cached in the application. If you use identity, the problem is that there is no cache in the application. So you don't have to read the sequence, so that's good. You have less round trips to the database, but in the database, it is not cached, depending of your database. In Postgres, by default, it is not cached. In Oracle, I think it caches 10 values. So yeah, it's something that you need to know. You don't want to read a sequence and update the value in the database for each row. You need to cache it. You can cache it on the application side. You can cache it on the database side. But it's important to know and maybe to change the cache. Here I'm mentioning that what we have seen before on Postgres with this big serial data type was before Hibernate 6.4, where now was before 6.5, because now it uses the SQL standard generated as identity, which is the SQL way to have an auto-increment data type. And yeah, and you can see what it generates. Nothing more than that. And this means that it doesn't set a cache in the database itself. So you avoid round trips to the database, but within the database for each row, it will update a sequence, and this sequence is a single point of serialization. So probably you want, if you use that identity, probably you want cache within the database, at least, so that each time it doesn't have to increment the value. And you cannot do that from Hibernate. You can do that if you go to the sequence, alter the sequence, or alter the colon when it is defined as identity, and set a cache. So basically, it's easy, but if you don't know what happens, then maybe you don't know that you are not efficient enough, and at some point you have to look at the SQL generated and do something just to get something that can scale. I mean, if you insert one row every 1 hour, you don't really need to cache it. But if you have some use cases that ingest a lot of rows, you don't want this sequence to be a bottleneck. Of course, there are other solutions to generate an ID. If you use a UID, then you don't have this sequence. And so if you use the generation type UID, it will create a UID data type on Postgres, for example. And then the big advantage of it, so here, like with the first one, like with the sequence, Hibernate sends the value with it, but doesn't have to read the value from the database. It generates a UID that is unique because the chances of collisions is really low. So this is how you define it. And that's a good idea because in many cases, you want the identifier before it is persisted to the database. This is the reason why with a sequence, Hibernate first reads from the sequence before the insert. With the identity, Hibernate doesn't know the identifier before the insert. And you have different types of UIDs, and in Hibernate 6, you can use the UID generator to have different UID generators. A big problem with UID for most databases, actually for databases that uses B-tree indexes, most traditional databases use B-tree indexes, Postgres, Oracle, SQL Server, MySQL. The big problem is that a random UID will be scattered in different places within the index. And this is not really efficient because each time you touch a different page, and then you are not very friendly with the cache, you are not very friendly, you are doing random reads, so not the best. Today, it's better to generate a UID that starts with the same value, but there is no built-in generator for that. There is a generator called time, which uses the time in the UID, but put in front the MAC address, which may not be exactly what you want, but you can build your custom generator, use UID v7, for example, where you have one part that comes from the time and another one that comes from the from a random value. But again, this really depends on your database. For example, in NuGabyteDB, we have a different storage. We have the same query layer as Postgres, but we have a different storage using LSM trees like RocksDB. And in LSM trees, you don't really care about the randomness of UID. So really depends on your database. And there is something else. We have seen different ways to generate the identifier, and in some cases, you have less round trips to the database than in others. But if we look at the round trips with the insert, and also I said that if you show SQL, you see the SQL that is sent to the database. That's not exactly true. You see the SQL that is sent to the database driver from the application, from Hibernate to the Postgres driver, for example. But the driver itself may do something else. And for example, when you see multiple inserts, it can be sent in multiple statements in one command if you set the batch size, which is already good because even if you have multiple insert statements, it will be sent multiple ones at a time. So you save on network round trips. But again, depends on the database. Some databases will do something very clever with that. Postgres will send them as one command, but it will still be multiple insert statements. If you change a parameter that is on the Postgres driver level, write batched insert, rewrite batched insert, then the Postgres driver, when it sees multiple inserts that are quite the same, it will transform it to a multi-value insert. So this is not a log from Hibernate, this is a log from Postgres, because the drivers has changed that. And this is much better because you have only one insert statement with an array of rows rather than multiple inserts. But again, you need to know the database. Yeah, question?
Does it mean that actually when you send an insert command, it doesn't insert it like on the spot, it waits and it puts it into a buffer until it tries to find others?
So the question is, does it wait for that? If you use rewrite batch insert on Postgres, this is useful only if you set the batch size on Hibernate. So if Hibernate sends multiple statements, then Postgres will transform them, but the Postgres will not buffer them. So if you want to see this kind of thing, of course, you can look at the logs in the database, but that's not always easy for a developer. You have something more than show SQL. You can show statistics in Hibernate, and here you have a clue. For example, at the top there, you can see that it is executing, so preparing 450 statements and executing 450 statements. So this is not batched. When it is batched with the batch size of Hibernate, then it is sent as only 5 batches, so 5 statements sent to the driver. The optimization that the driver itself does, you do not see it at this level because it happens on the driver, but the only thing is that you will see the time to be faster. So the first one was with batches 1, the default, the second with batches 100, so this is why you have 5 batches. And if you use rewrite batch insert, you will just see that it will be faster because you save on network round trips. So basically what I'm saying is that it's good to look at what happens, but it may not be easy because what happens can happen at different levels, the client driver or the database server. And also, batching is not always as easy as it seems. If you have multiple inserts that are the same, going to the same table, then the driver can do something. But if they are interleaved between multiple tables, or if there are intermediate statements between them, then it cannot batch them. And yeah, also something that I wanted to mention, when you use the identity generator, then it doesn't read the sequence to get the value, it inserts directly. But Hibernate needs to know the value, and then it will use an insert returning. So you insert a row, you do not mention all columns, but you return all values so that you know the ID that has been assigned by the database. So that's nice, except that this one cannot be batched, because you can batch only something that doesn't return rows. So you have one optimization on one side to avoid the call to the sequence, an optimization on the other side to batch the statements, but one works against the other. So you need to really understand where is your bottleneck. Maybe it's better to read sequences every 15 rows rather than not being able to batch the statements. Also, if you interleave multiple tables, so here, for example, I'm inserting users and many messages, and then next user, and then many messages. This cannot be batched as if you start to insert all users and save them, and then insert all messages. So again, you have different ways to do it. There is the default way. There are different ways. Some are good for some databases and depend on your case. For example, reading the sequence, that also depends if you are on the network round trips. For example, when we run a distributed database, we want to avoid reading too often from a sequence because a sequence is only at one place, doesn't scale really well. So basically what we have seen, and I will look if there are questions on Slido. Basically what we have seen is that you have multiple combinations, and it's good to understand what happens in the database. Of course, this show SQL, you will not put that in production and read all SQL statements. But it makes sense when you are trying something different, a new mapping, a new design, to look at what is generated for your database. And if you are moving from one database to another, with Hibernate, you just change the dialect, but it may be good to look at what is generated for the new database. Maybe it's optimal for one and not for the other. Let me check the Slido thing. How do I refresh that? No. Okay, maybe we will look at that at the end because... Is it fresh? No, yeah. So is it possible to insert your custom generator into Hibernate? For the UID, yes, you can. It may not be as easy as just setting which one, but you can. And also maybe you can contribute to Hibernate to add another one. Is there any chance of getting access for these slides? Of course, I will put a QR code for the slides, and anyway, contact me on LinkedIn, quite easy, Franck Pachot, database or whatever, you will find me. And yeah, okay, let's continue. So the next point is about fetching mode, with an example of one-to-many and the thing that you want to avoid. Oh, sorry, you don't see the slides. So again, what you want to avoid is too many calls to the database, too many statements. This is not only a problem with network calls. Even if you put everything in the same server, those statements are parsed by the database, they are read, there are context switches. A lot of things happen for each statement that doesn't happen for one big statement. So basically, you want to avoid this kind of thing, but it's often the default. So you need to think about the fetching strategy. Good to have the fetch type lazy because you don't want to read all your database when you're reading a graph of objects, but the default fetch mode select does a lot of select. Would be better to put it in plural. So yeah, you probably know that, and plus one queries. But again, you can batch things. The solutions to many kind of those things, to many identical statements, is batching. So if you set the batch size, then it generates only one statement with an array, which is good, very similar to the multi-value insert. But again, that will depend on your database. So this one is good in Postgres because Postgres accepts a parameter. The $1 is a parameter in Postgres with an array, with multiple values. But if you do that on Oracle, Oracle doesn't have that. In Oracle, the same mapping will not generate one parameter with an array. It will generate many single value scalar parameters, which may not be as efficient because then, even if those are parameters, it's a big statement that has to be sent to the network, parsed, and also there are some limits. If you reach 1,000, then you have this maximum number of expressions. Don't worry, Hibernate can generate many 1,000 statements like that with or between them. But I've also seen, another maximum where the total number of parameters was more than 65,000, and then it just crashes your session. This crash of session was a fix because before I've seen versions of Oracle where it was crashing the instance, which is not very nice, just when you run a query. So again, depends on your database. The fetch with a select and the batch size is probably okay in Postgres, probably not in Oracle. Something else that you can do, using a subselect. So instead of passing an array or a list of scalar values, just running the statement with the select where the values come from, which looks quite good because the values actually are in the database. You have read them, and then you want to need to read more detail with the one-to-many, then why not just run again the statement? So that's the subselect strategy, which is quite good. It's doing a join in the database, and databases are optimized with join. It's an in, but basically it's implemented as joins. And so maybe it's not optimal in the way that you read 2 times the same table, but if you think about it, this is not a big problem because it's 2 times, it's not n times, and what you have read stays in cache, so probably okay. But there is something else to think about it, and that's not only for this one, even for the other ones. You run multiple statements. It doesn't give you the same result as running one statement. If you are alone on the database, it will give you the same. But if you have multiple users, the database state changes. So if you read everything at time t or time t plus 1, it can change. And this depends on the isolation level. And then you have to go to a detail where at the beginning you didn't want to go to this detail when you used an ORM. Basically, if you run in read committed isolation level, which is the default, every statement, even within the same transaction, every statement will read as of a different state, a different read time. When you write, it will take care about the consistency, but the reads, you read different states. If you do everything with one statement, there is only one read time. Not saying it's good or bad, just saying that it can change the result in the application if you have race conditions. So there is another one, which from the database point of view is probably the best, doing a join, because databases are there to run SQL queries that can join multiple tables rather than running multiple single table statements. So this is what is generated for the same mapping, except that you change the fetch mode to join. Only one statement that reads everything. But then the fetch type switches to eager, even if you do not mention it, because if you join, you read everything at the time, and then you will read everything. So that's the first problem. So you solved the consistency, because per statement it is consistent even if you use the read committed by default isolation level. But you read all columns from all tables, and that may be too much. So you want to reduce the number of run trips to the database, but maybe you read too much for that. And and you don't always rent all tables. First, I said you read too many columns. I've seen many people thinking that because you use a row-based database, as opposed to columnar database, reading one column or all columns is the same, because basically you read a row. But physically, you probably don't read directly the row from the table. You read through an index. So let's say you have an index, you have the key and other values in the index. And for each index entry, it will go to the table to have the column values that are not in the index. It's kind of a join. You don't see that as a join, but between the index and the table, it's kind of a join. And what happens there is that you read the index, and then it has to go to the table, and probably the information in the table is not ordered in the same way. It is scattered everywhere. So again, you have those random reads everywhere, and that's not very efficient. But if you read only the columns that are in the index, you don't have to go to the table, so you save that. Then it makes a big difference if you read only the columns that you need, especially if you created the index knowing the columns that you will read, makes a big difference with a select star reading all columns. So you can also mention the columns. So this is another way to do a join, and probably better, you don't want to do a join for all queries, but for specific queries, then you write the query with a join. But again, this one will read all the columns. So that's good, except that you read too many columns. You have also an alternative. You can also use entity graphs, where you define the different graphs that you want to read, and then instead of building a specific query, you just mention which graph you are using. Just mentioning it. But if you want to read less columns just because you have a use case that is that you want to optimize, you have created an index with all the columns that you need. For example, in Postgres, you can include columns in the index in addition to the key. If you want to use that, then you can also query only the columns. But the problem is that then you return an object that you cannot directly map to an object that you have. So brings more complexity, optimizes the query in the database, but brings more complexity. So different choices, basically, and they are different when you go from one database to another. I'm not saying that you have to understand every query that your application generates, but you have probably some use cases that are critical from a performance point of view, and those ones, it's good to have an idea about what is generated to the database, how many statements, does it read all tables, does it read all columns, do you have the right indexes on them? And let me see. Don't know if we have to refresh it or not. Okay, so if there are no questions, not trying to refresh it. Perfect. Let's go back to the slides. Checking the time, and I will go to a few other points. Yeah, important point. Very often it's a trade-off, so you need to understand what you want to optimize. Something that I see a lot, and that is problematic, queries generated for pagination with a limit and offset. You can do that in SQL, and it's probably always bad. So you have two ways in Hibernate. Let me just show everything. You have two ways in Hibernate, especially in latest versions, to do pagination, the bad and the good one. The bad is offset. Basically, what I tried to show with this is that the first page is okay, but then the second page has to read from the beginning again to start at the offset. So if you read only one page, then the first pagination is okay. If you read many pages, then it will not scale. The right way of doing pagination is not with an offset, where you have to read everything and then skip the first ones, but remembering the last key that you have read and just running a query that starts at this key. Then in the database, in the index, it can go directly to read what is needed. And you can do that with key-based pagination. So you mention which key, your result, probably if you do pagination, you have an ordered result, and you have a key there, you mention it, and then the second page will just start where the first has finished. Another thing that I mentioned that fetch type eager is probably not the best, because with that, you define that every time you read the entity, you will read all the child, for example. Think about it. If you have an entity where you always rent the child rows, then maybe you don't want to map that in two relational tables. In SQL databases, you can put documents as a JSON. So if there is something that always come, more details that always come with an entity, maybe it's better to store it as a document without having to join and thinking about lazy or eager fetching. So this is just an example where you can define JSON. All databases today store and are optimized for JSON. You can also add indexes on them. So basically, it works. So think about it. If you think that something needs eager fetching, maybe you just need a document in one column. And the last thing I will mention that I've seen a lot, and it's probably a default that is bad for mostly all databases. It's worse for some databases. By default, Hibernate tries to reduce the number of SQL statements. So basically, it prepares an update statement that updates all columns. The worst that you can do, I think it's something general. The first that you can do, if you have only one thing to change, is changing too many things. And depending on the database, In Postgres, it's not a big problem because anytime you change a byte in a row, then the whole row will be copied elsewhere physically. But for example, if you are on Oracle, it will make a big difference. If you have only one column to update, this will be much faster, more scalable than updating all columns and setting the same value. So in most cases, you want dynamic update. So instead, so that's an example on the previous query where I saved this JSON and I changed only this JSON. But I see that my update not only updates my JSON that was in profile, but also the name that I didn't change. If you use dynamic update, it will generate an update, only for the column that has changed. And if you start to look at what the database is doing when you update something, you will realize that it's crazy to update. You may think that the database will realize at some point that you update a value to the same value and then skip all that. But the database cannot, because if you declare the intent of changing a column, even if you put the same value, you declare the intent, and then the database may have to run triggers on it, may do something on it. For example, if you do logical replication from the database, if you declare the intent that you update a column, even if it's the same value, the logical replication, the change data capture will generate something. So if you know that the value doesn't change, much better not to put it in the update in the database. You will, of course, have smaller statements. You will generate less redo log or write-ahead logging. You will save this copy of all values in the undo block, redo blocks. A lot of things happen in the database when you update something, and you can skip that. Okay, so basically in those last tips, yeah.
Sorry, I have a question. It seems like dynamic updates seems like a super great default. I mean, I don't see any con. Can't we have it as a default? Is there?
So yeah, the question is why it's bad and the default. Historical reasons. There are some cases where it was better, or some databases where it was better to use always the same prepare statements. There are also some consistency considerations for not changing the default. For example, some databases, very few, but some databases have row level logs. Many databases, Postgres, Oracle, log the whole row when you update a single column. But for example, in Yugabyte, we log only the column. So it makes a difference. Even if you do not change the value, do you want it to be locked so that nobody change it? So it has a bit of semantic change. I would be better with default dynamic, but it's probably not a good idea to change it for the application behavior. But it's not because it's the default that you have to use it. Huh? Okay. So just 3 things to think about. Dynamic update. You have also the same with dynamic inserts. If you insert without a value for all columns, maybe you don't want to mention all columns. Yeah, something I didn't mention also. When you update a column, even if you put the same value, if you have an index on this column, it will have to maintain the index, even if it's the same value. And the consequence of it, updated the index, more writes, more redo logs. There is a lot that can happen there. Okay, let me just, sorry. So this is just, we have 4 minutes. I will look at the questions. If you want the slides, I have no link to the slide, but this is my LinkedIn, just ask for it. And I'm easy to find on Twitter, on LinkedIn, on many things. I don't know if we upload the slides on the website, but do not hesitate to ask for it. And more than just having the slides and thinking, okay, I should do that. My idea is more to tell you that you need to think about what is generated. I didn't mention other databases because I know them less. And maybe I said something that are bad. Maybe there are some databases where dynamic update is a problem. I don't know them, but how many dialects do you have in Hibernate? I don't know what is generated for all of them. So the idea is really try to understand what happens. If you can talk with your DBA, I know it's not always easy, but if you can talk with your DBA, I was a DBA and discussing with developers where I understand what is generated. I learn what is generated by Hibernate, and the developer learns how the database use it. That's always good. So if you are in this DevOps mind, probably you can discuss with someone who knows how the database works. Okay, last question. Does dynamic update only update the changed column and skip the not changed one? Yes, that's the idea. Hibernate has the previous value, because it has the object, has the new value, and then knows what has changed. Of course, if in your code you change it to the same value, Hibernate doesn't know that it's the same value. It will not compare the two of them. It's just that you have changed it or not. So maybe it still generates too much. But think about it. It's an optimization, but it may also change the semantic of what is happening. The intention to update is there even if you put the same value. If you have a trigger, for example, in a table, if you have a trigger, something that is automatically done when you update a column, do you want this trigger to be raised if you explicitly updated to the same value? Or do you want the database to skip it? Skipping the trigger really depends on what you do with the trigger. So, yeah. Okay, we have 2 minutes. Is there any more question? I will just let that. Does dynamic update include non-changed entities in batch updates? Does dynamic update include non-changed entities in batched update? Yeah, maybe you can explain, because if it's not changed, how is it batched? Okay, I'm not 100% sure, but if you don't change anything, I think it will not be in the batch. Not depending on dynamic or not, but I may be wrong on that. Okay, I'm not 100% sure, so I think that it doesn't depend on dynamic updates. Dynamic update is really about the columns. So as soon as you have updated a column, then maybe something that I don't know, if you have changed one column for one of it, another column from the other, maybe this will break the batching. So maybe that's a cons of the dynamic update. You may be able to batch more because it's all the same statements, especially when you have the driver itself putting it all together. So yeah, but better to check it and check what is generated in all cases. Okay, that's all. Thank you. I'm at the conference. Do not hesitate if you have questions about that, but also if you have questions about distributed SQL databases. That's the thing I'm working on now. Thank you.